This is the first video of a series of short Python tutorials for beginners. Hopefully by the end of this short little series, you'll have a solid understanding of how to code. That's really it. Since I'm new, if you enjoy this, please subscribe. Thank you. It's only video number 1, so we're not going to go too crazy. Alright, we're just going to download and set up Python and a text editor so we can start writing code just for this video today. Make your way to python.org, go to the downloads. I'm going to download for Windows. Find the Windows installer down here. Whatever, just install like a normal program, whatever. Just make sure you select add python.exe to path. Go install now and just let it do its thing. Setup was successful. You can check if that's true or not by opening your CMD, type in Python. I'll show you what version you have, and it will also open up a nice Python environment for you. You can write code there even. See? Now on to the next step. Make your way over to code.visualstudio.com. I'll leave the links for these in the description as well. And click download for Windows again. This is no different from what you would do to install any other program on Windows. It's not really need a tutorial. It's just there's a couple extensions to install after when it's done. Yeah, accept all that stuff. Make sure add to path is checked. Install. It's done, so you can launch it now. Now when you open VS Code, you'll see this screen like this. But first, you're going to want to go to the extensions tab over here. Make sure these 3 are installed. Pylance, Python, and Python Debugger. You can search them, and they're installed for me already. But yeah, if you want to run Python files, you have to save the extension as .py. You have to make sure it's .py, otherwise it won't run as a Python file. It won't be a Python file. So, start out with a simple little hello world. Classic, you know, test if everything's working correctly. If you want to run the file, go into the terminal tab that's at the bottom and just write Python, name of your file, .py. There you go. Printed hello world. Print basically just puts something on the screen. That's it. Just whatever you want. Print whatever, it will put it on the screen. You can also just run the Python file from up here where it says run Python file. Today we're going to start off with probably the most important thing in programming, which are variables. So let's just get right into it. Start out by making a whole new file so I can have this properly organized. Variables.py. So what even is a variable? Well, a variable is basically just a name for a piece of data that you want to store or mess around with in your program. You can call it whatever you want, and it can have a value of whatever you want. To assign a variable, you have to first write the name you want to set the variable to be, followed by an equal sign, followed by the value of whatever you want the variable to be. I'll show you right now. For example, my name equals Joe. The variable is called my name, and the value is Joe. You can also set the value of a variable to equal an integer or a number. For example, my age equals 40. We'll do a print statement as well. Make sure this is working. Print my name and my age. Save it. Run the file. Oh, variable, I meant variables. Here we go. There we go, it's working correctly. Joe 40. You can also set the value of multiple variables on the same line by separating the variable names by commas and the values by commas. For example, my name, my age equals Joe 40. And this should work exactly the same. Here you go. When it comes to naming your variables, there's a few rules to follow. Firstly, variable names can only contain letters, numbers, underscores, and cannot start with a number. So this print my age is going to work, but if I start the variable with a 1, it just turns red. You can't even run it. There are some words as well that are forbidden to use as variable names because they already have a use in Python. Things like prints. So you can't do stuff like this. Print equals 1, if equals 1, while equals 1, class equals 1. You can't do any of that. You can't assign values to any of these. You can't use these as variable names because, see, they're all different colors. It's because they already do something different in Python. They already have a predefined use, so they're unavailable to use. But you can use anything else if it's not used by Python already. For naming conventions, there's 2 main ones. The first one is camel case, which is like this. The first word is all lowercase, and then the first character of every word after that is capitalized like that, like I've been doing for most of these examples. The next way is with underscores between each word, like that. It's both the same, just whatever you prefer. I'm going to go with the underscore method for the rest of these videos because that's what I'm used to, but you can use whatever you want. Variable names are also case sensitive. So for example, my age, all lowercase, I'll do 40. These are our 3 different variables because the cases are different, the capitalization is different. So make sure when you're using variables to use the correct capitalization for whatever variable you set. The equal sign has a different meaning than it does in math. You can kind of see what I mean. Say we have a variable a that's equal to 3, a variable b that's equal to 5, but then we set the value of a to equal the value of b, and we're going to print the answer. Now we can run this. See, they both equal 5. Instead of a equaling 3, we changed it to the value of b down here. So before we ran it, change the value. Now, the single equal sign is an assignment operator, but it's not the only assignment operator in Python. Let's say you have a variable called x and it's equal to 10. You want to increment this variable by 1, the value of this variable by 1. So change it to this, x equals x plus 1. Now if you print x, you'll see it updated from 10 to 11. Basically, it does this on the right side and assigns the answer to the variable on the left. You can skip this little bit of writing by simply changing this to plus equals 1. Does the same thing as before, it's just shorter. Now the same thing works for every operator that I just talked about in the previous part. For example, minus equals, change from 10 to 9. Or how about this? This will be 10 times 2. See 20. 10 to the power of 2 is 2 asterisks instead of 1. Same works for divide and floor divide and modulus. You can also do math operations on variables. For example, let's say you have variable a equal to 5, variable b equal to 3, and you want to see the sum of these two variables added together. Then you can do print a plus b, just like that. Simple variables. See, I almost did it again. 5 plus 3 is 8. You can also do this with subtraction. Just change this to minus. So 5 minus 3 will be 2. Other than addition and subtraction, you can also do multiplication, division, floor division, modulus, and exponents. Just to show you all the operators, I'm going to print all of them. So this will be for minus. This will be for multiply. This will be for divide. This will be for floor divide. This will be modulus. This will be exponents. There you go. You mess around with that. Hey, what's up, guys? This one's going to be about data types. First off, all a data type is just referring to the type of data that a variable can store. I'm going to start out by going through data types that we've already seen in previous parts: integers, floats, and strings. A string just means text, literally just words. To declare a string, all you have to do is enter your variable name, followed by an equal sign, and then wrap the value of your variable in either single quotes or double quotes, like this. Name equals Joe in single quotes. I'm going to do name 2. See, all 3 of these are strings. Doesn't matter if you use single or double quotes as long as they match on both ends. So you can't do one side single quotes and one side double quotes like that. You can also concatenate strings, for example like this. If you want to say add these 2 strings together, you could do something like this. Try full name equals Joe plus sign Johnson. I'm going to print the full name. See, you got Joe Johnson, just like that. Now I can add a space at the beginning there. Now it looks okay. When it comes to formatting your strings, like let's say you have a string and you want to include a variable you already have in the string. The one I usually use is the f-string way, but I will show another way as well. So say you have these variables already, name and age, Joe 40, and you want to make a sentence using these values. You can do something like this. I'm going to call this variable formatted string for obvious reasons. And you're going to want to start, before you put the first quotation mark, you're going to want to put an F like this. And then my name is name, and I am age, years, old. Print formatted string. My name is Joe and I am 40 years old. You start before the quotations with an F, and then each variable that you name is inside curly braces inside the quotation marks. Really that simple. Another way is using the dot format method. You do that by, it's the same, just remove the F, remove the variable names here, and at the end of the string, put dot format, name, and age. What that does, these empty braces are the placeholders, and these two are the values. The name and the age variables are the values that get assigned to the placeholders after. If I save and run this, it does exactly the same as the other thing, as the way using F strings. But in my opinion, F strings are shorter and easier to write and read, so I use those. The next data type I'm going to be talking about is integers. To declare a variable as an integer, all you have to do is set it number equals 40, something like that. It's the whole number without a decimal. Some languages you'll have to specify if a number is an integer or not, but Python you don't. If it's a whole number, it just knows it's an integer, so it will just automatically do it. But yeah, an integer is just a whole number, no decimals, any number, even if it's negative, still an integer. Pretty easy to explain. Don't need to spend much time on it. The next data type we have is floats, which is even easier to explain because I pretty much just did. It's the same. It's a number, except it has a decimal point. So 40.5, 40.05, anything like that. Hey, I don't know how I forgot this one. We have another data type called Boolean, which just means true or false. So say we have a variable called subscribed equals true, or subscribed equals false. That's a Boolean. Before I start talking about the other data types, first I want to talk a little bit about typecasting. If you ever want to change your data type from one to another, that's called typecasting. You can do that with three basic functions in Python. Those are going to be ints, floats, and string, or stir. The int function takes in a float or a string and converts it to an integer. The float function takes an integer or string and changes it to a float, and the string function or stir function takes an integer or a float and converts it into a string. I'll show you these all in practice now. To change a float into an integer, just type int and pass in the number. I'm also going to wrap this in a print statement so you can see. So you removed the decimal point, changed it from a float to an int. If you want to change an integer into a float, you do the same thing, but instead of int, you'll just use float. So float, or wrap this one in a print statement as well. See, it added the decimal point. The same thing for the string function. Just put stir, whatever it is. Let's use a float. It's not really a point to printing this because won't show the quotation marks in the print statement anyway, but it does work, trust me. So we've talked about a few data types now and ways to typecast. There's a few more data types I want to talk about in this video. The next data type is a list. A list is used to store a collection of data that's normally related. Let's say you want to store multiple users' ages. Instead of having multiple variables like this and typing them all out one by one, you would have something like this. To declare a list, enter the list name followed by square brackets. You can either leave the square brackets empty for values to be assigned later, or if you already know the values, you can just enter them separated by commas. To access the values in the list, use their index or their number position in the list. See, there's 4 items in there. The list index also starts at 0 instead of 1. So if I print user age 1, you might think it would give me 40 because that is the first one. But no, that would be 0. It would actually give me 41. See, you can also use the list backwards. For example, -1 will be the last item in the list. -2 will be the second last item in the list. -3 will be the third last item in the list. And you get the idea. You can also assign just a slice of the list into a variable as well. If you want, you create the variable, access the starting index, the index you want to start at to cut out, and the index you want to end at, like this. See, that starts at index 1 and cuts out 41, 42, 43, 1 to 4. The starting index will always be included and the ending index will always be excluded. So that's why the 44 is not included as well. To modify items, access the index like before and simply assign it a new value like you would a variable. Now I'll print user age 1, which I should have just changed to 55. To add an item to your list, use the append function on your list. Go user age dot append and pass in the value, whatever you want to add to your list. I'm going to print user age again, and you see I added 100 to the end of the list. To remove items from a list, enter del for delete and access the index of the value you want to remove. Del user age 2 will remove the third index item out of the list. No 42. This works with any of the indexes, of course. You can delete the first one. Now 40 is deleted. You can also use the .pop method on your list to remove the last item of the list. It removed 44. Tuple is the same as a list. The only difference is you can't modify the values that you set in one. You can add and remove things, but you can't change them. To declare a tuple, it's the same as a list, but instead of square brackets, you use parentheses. You access the values with their index just like the same as the list. So if we did print user age 1, this will give us the second value of the list, 41. Dictionaries are collections of key value pairs. For example, if you wanted to store users' names and ages, you might use a dictionary. To declare a dictionary, instead of square brackets or parentheses, you use the curly braces. Just like with lists, you can start them off empty, or you can fill them with values if you already know them. The keys and the values are separated by colons. See, the key here is Joe, and the value is 40, so Joe is 40. If you have a multiple separated by commas, I'm going to put John. John is 30. To access items in a dictionary, it's quite similar to a list, but instead of the index position, you just type the key. For example, my dict Joe. And we're going to print this so you can see that's Joe's age. Joe's 40. If I change this to John, John is 30. To modify items, you do the same thing, except you just assign it a value, just like you would a variable. My dict Joe equals 45. Now we'll print. Now Joe is 45. To add items, it's the same thing. My dict. See, I added Jeff since Jeff didn't already exist. I added him. To delete an item, once again, it's the same thing, but you just enter del and whatever key you want to delete. Now Jeff is gone. Hey guys, welcome back. Today we're going to learn how to make your program interactive in Python. So far it's been kind of boring. All we've done is assigned variables and printed them on the screen. We've never actually done anything where the user actually interacts with the program at all. I'm going to talk a little bit about the input function. The input function allows you to just, for example, print a string on the screen and it will ask you a question and you'll input whatever you want. I don't know if that made sense, but I'll show you. Start by going my name equals input, a string of the prompt that you want, for example, a question. And we'll do another one for age. My age equals input. How old are you? And then we'll do print, start off with F strings again, and do hello, my name is my name, and I am my age, years old. We made this a file called interact.py, so do python interact.py. See, what is your name? Enter Joe. How old are you? 40. Hello, my name is Joe, and I am 40 years old. So the strings in the parentheses, how old are you and what is your name? Those are the prompts for the user to enter. Whatever is entered there gets assigned to the variables my age and my name respectively. It is then formatted with F strings just like before, using these variables my name and my age. Real quick, I want to mention comments. I don't know why I haven't yet. If you want to exclude something from your code but not completely remove it, you can comment it out with a hashtag symbol. Now, when I run this, it will run everything besides the commented out codes that are green. Still asks what's your name. See, that is ignored now. If you want to comment out multiple lines, because this only comments out one line, if you want to comment out multiple lines, do 3 quotation marks in a row, like this, and end it wherever you want to close it. Now this won't print anything anymore. It only asks what is your name, because that's the only one not commented out anymore. The print function, like I talked about before, is just used to display information to the user. You can use either 0 arguments or more than 0 arguments. The arguments are what goes inside the parentheses in the print function. If you just leave it empty, it will print an empty line. When it prints this sentence, it's going to have a blank line above it because I printed an empty line. There it is there. Sometimes you may have a long message you want to print. To do that nicely, we can use the triple quote symbols again, just like in comments, but instead of commenting out code, put it inside the print function, and it will span your message over multiple lines. For example, if I change these double quotes to triple quotes, and I press enter to start a new line wherever I want the line to stop, run it, show 40, see it stopped the line where I put it, do this again, just like that. Sometimes you need to print things that are unprintable, like new lines and tabs and quotations, some quotations. For these you need escape characters. This one is actually very easy. All you do is type backslash and whatever character you're escaping. If you backslash T, it will put a tab. If you backslash N, it will put a new line. And if you escape the single and double quotes, it will show the single and double quotes like this. See, the first one is tabbed in, then it's a new line, and then the quotes, which normally wouldn't show in a print statement unless escaped like this. Today we're going to be looking at adding logic to our programs using conditional statements. Basically making our program check whether things are true or not and acting based on that. Alright, the first thing I want to talk about is condition statements. I have a few written down here already. They're all going to evaluate to true, just to show you as an example. But the first one is equal to. If you want to check whether two values are the same, use the double equal sign. So this is asking, is 8 equal to 8? The next one is not equal to, which instead of the double equal sign, we put an exclamation mark and then an equal sign. So the next one is asking, is 8 not equal to 4? The next one is greater than. This is the same as in math. So this is asking, is 8 greater than 4? The next one is the same, but it's less than. So the next one is asking, is 8 less than 10? The next two are the same as the last two, as well as the first one. So this is asking, is 8 greater than or equal to 4? Or is 8 greater than or equal to 8? We return true or false. And then the next one is the same, obviously just smaller than or equal to true or false. So let's run this now. We'll see they all return true. If you want to string together multiple conditions, you can do so using the keywords and, or, and not. Example, the first one will only return true if both 8 is equal to 8 and 8 is greater than 4. The next one will evaluate to true if 8 is equal to 4 or 10 is greater than 8. And the last one will return true if 8 is not equal to 4. For practice, I'm going to start by creating a variable called user input and asking a user to enter a number. If user input is equal to 1, print hello world. Elif, which is short for else if, user input is equal to 2, print how are you. Else, print enter a valid number. So before I run this, let's recap. The variable user input will be created with whatever the number the user enters. If the user enters the number 1, hello world will get printed. Else if the user enters 2, it will print how are you. And if the user enters any number besides 1 or 2, it will print enter a valid number. So let's run this right now. Enter 1, hello world. Let's try the other one. Enter 2, how are you. Try one more time. Number 3. Enter a valid number. Now it's time to talk about for loops. For loop is basically just a block of code that just repeatedly executes until a condition is no longer valid. You can loop or iterate through many things, including lists, dictionaries, strings, and tuples. We'll start by creating a list called animals and filling it with 4 different items. So we've got a list of animals: dogs, cats, horses, and cows. And then we're going to do for animal in animals, print animal. Run this. The program runs through the for loop, assigns dogs to the variable animal, and then prints the value of animal. And then the for loop runs again, instead this time with cats, and assigns cats to animal, and then prints animal. And then the next time it's the same thing, it loops again, assigns horses to animal, and then prints animal. And then the last time for cows, assigns cows to animal, and then prints animal. You can also display the index position of the items in the list using the enumerate function. Simply change this to for index and put animals in the enumerate function. You'll also need to print the index too, like so. Let's try this again. Now we're going to look at how to loop through a dictionary. To loop through dictionaries, you can use the items, keys, and values methods. If you want both the keys and the values, use the items method. It's the same as looping through a list. So type for key, comma, value in people.items for key, comma, value in people.items, print f string key curly braces key value value. Now let's see what we get. The first key is the name. We have Joe. Second key is age. We have 40, and the third key is city, and we have LA. If you want only the keys, simply remove this and change this to keys. Run it again. There we have just the keys, and the same works for the values. Change this to values. Run it one more time. We have just the values. To loop through a string, it's the same idea. You see here, the I just iterates over each character in the string and prints to the screen. If you want to loop through a sequence of numbers, you can use the range function. The range function generates a list of numbers, and you can use it by passing 1 to 3 numbers into the function. The first number being the starting number, the second number being the end number, and the third number being the step number. For example, this here will generate a list of numbers starting at 1 and counting to 10 by 2. If you don't want to include the step number, you don't have to. If you don't include the step number, the list of consecutive numbers will just be generated. Basically, the default step number is 1. You also don't have to provide the start value either, but if you don't, remember it starts in Python, we start at 0, so this will be a list from 0 to 9 instead of a list from 1 to 10. We can loop through this list by putting for I in range 10 print I. Let's run it now. See, it's a list from 0 to 9. The next thing we're going to talk about is while loops. Pretty self-explanatory. Pretty much while something is true or while something is happening, do something until it is no longer and then stop. But with while loops, you have the potential to make them infinite, which is not good. So you have to make sure you specify a way for it to stop, usually in the way of a counter that counts down, and once it reaches a certain number, then the while loop will stop or something like that. I'm going to start by creating a variable called counter and setting it to 0. And while counter is less than 5, we're going to print high and then increment counter. Increment counter by 1. So this should, since we start at 0, this should print high 5 times and then stop. As you can see, I recorded this part already. Unfortunately, my mic was muted, but it works. You could also use break to stop a loop. For example, you could do something like this. While counter is less than 10, if counter is equal to 5, break counter plus equals 1. So the counter will start at 0 while the counter is less than 10. If the counter is 5, we'll exit the loop. Otherwise, we will print the counter and increment the counter. Run it again. If you want to skip an iteration, you can use the word continue. You do something like this. While counter is less than 5, counter plus equals 1. If counter is equal to 3, continue counter. So the counter is 0. While the counter is less than 5, increment the counter by 1. If the counter is equal to 3, skip everything. Otherwise, print the counter. Run it one more time. 1, 2, 4, 5. 3 is skip. Next, I'm going to talk about try-except statements. Try-except statements are used to control how the program responds whenever an error happens. So if you try to do something like this and run it, see there's a 0 division error because you can't divide by 0. But if you want to change this behavior, you do something like this. Try total equals 10 divided by 0, print total, except 0 division error as E. That's going to be the variable name given to the error that's as E. Now print whatever message you want. So now it's a custom error message. So you try the code and then make an exception for whatever error you're expecting and enter your own custom message. Quite simple. Now there are many types of errors you can get. It's not only 0 division error, obviously, but the process is exactly the same. I guess I should mention a few other errors. One of them is import error. Like if you're trying to import a module and let's say you make a typo or something, you might get an import error. If you enter the wrong index number, you might get an index error. If you're looking for a key in a dictionary that doesn't exist, then you might get a key error because key is not found. You might have the incorrect type to do an action or function, so you'll get a type error. Those kind of things. That's also not all of them. It's just a bunch of examples. The documents for Python has a list also of error types. You can look through that yourself. Yo guys, welcome back. It's part 6. This one's going to be about functions. And we're going to talk a little bit about modules as well. A function in Python is just a reusable block of code that does something. You can create your own functions, but there are also functions built into Python. Depending on the contents of the function, it may be required to pass data into them to do whatever it's supposed to do. The data is known as an argument, and you pass them to the function by enclosing their values in parentheses separated by commas. For example, print is a built-in function in Python, where print is the function and hello world, the string, is the argument. To define your own function, start by typing def, followed by whatever you want the function name to be. I'm going to do add numbers as an example, followed by parentheses. Inside the parentheses, define the parameters that you want to be inputted to the function. A parameter is a variable that's used to store the arguments that you want to pass into the function. So I have parameters a and b followed by colon, and whatever is indented in the next lines after that colon will be part of this function add numbers. So let's create a variable called result, give it the value of a plus b, and return the result. Created a function that requires two numbers as the arguments. So when you go to call this function, I'm going to create another variable called sum. Add numbers, parentheses. Once again, in the parentheses, that's where you would enter the numbers that you want as the arguments. For example, 5, 3, and we're going to print the sum. So I've created a function that requires two numbers as the parameters. A variable is then created for the result of adding these two numbers together, and then the result is returned. And then down here, we call the function, we pass in the two numbers, and then we print the sum of these two numbers. Let's run this and see. The function added the numbers 5 and 3 together, and I got 8. Any variables declared inside of a function are only accessible inside of the function. This is known as a local variable. If you define a variable outside of a function, it's known as a global variable, and it can be accessed anywhere in your program. First, I created a global variable with a value of 5, and then I created a function. Inside the function, I declared a local variable called y with a value of 10. I then print two sentences using both the y and x variables. Remember, I can only use the y variable while in the function because it's a local variable, but I can use the x variable anywhere I want because it's global. We then print another message while outside of the function to prove that we can use the x variable outside of the function, and then we simply just call the function. So let's run it now. Now everything is correct, but if you try to use the y variable outside of the function and you run it, you'll receive an error because the variable is outside of its scope. There are a ton of pre-made functions, classes, and variables. They're saved in files called modules. To use modules, it's actually very easy. All you have to do is import them in the top of your file. I'm going to start by importing random. Random is used to obviously make random numbers. You can import the entire module just by doing what I just did, import random, or you can also import specific functions from the module. For example, instead of import random, it will be from random import rand range. We're also going to import rand ints. Now that these are successfully imported, we could just use the functions like normal. For example, rand range, generate a random number between whatever starting number and whatever ending number you set. So this will generate one random number between 1 and 10. Works. Obviously, there's many more modules. Anything you can think of, really. Someone probably made a module for it, or at least made something to make it easier. If you want to create your own module, it's very easy. All you gotta do is just save the file as a .py file, like normal, and have it in the same folder as whatever Python file you're gonna import it from. So I have this function here to add numbers. Say I want to import it to another file. All I would do is just create a new file, call it use add numbers.py. The other file was called functions, so I'll do from functions import add numbers. Alright, what's up everybody? This is part 7. If you made it this far, congratulations. Hope you've learned a thing or two. Today we're going to talk about working with external files using Python. So let's get right into it. Okay, so I have a text file here in the same folder as my Python files. Just got some lorem ipsum. And I also have a Python file called textfile.py. So in the textfile.py, we're going to start by simply just reading from the text file. We can do that with the open function. Start by declaring variable f and putting the open function. Inside the open function, pass the name of the file. In my case, it's file.text, comma, pass the second argument as r for read. Create another variable first line and put f dot read line function, and we'll do another one for the second line, and then we're going to print the lines and then close the file. So first, we open the text file and assign it to variable f, so the text file is now called f. We then create the first line variable and call the readLine function on our file that's now called f, and we do that again for the next line, and we print both lines, and then we close the file. So what happens when we run this? It reads the first two lines of the text file. The second argument in the open function is the mode. For this file, we used read mode, which is obviously for reading only. Another common one is write mode. You would change that to W. Obviously, it's for writing only. So if the file doesn't exist already for the action you're trying to do, the file will be created. If the file already exists, any data in the file will be erased. Another common mode is append mode. Change this to A. It's for appending data. Once again, if the file doesn't exist, it will be created. If it does exist, the data written to the file will be added to the end of the file. Another common one is R plus mode, which allows for both reading and writing. You could also use a for loop to read through a text file. You have the file open already and set to the variable f. So do for line in f print line and close the file. Run python textfile.py and there you go. I'll actually clear this so it's more easy to read. There you go. If you don't want the new lines after each line gets printed, you could specify the end like this, end equals blank. There. To write to a text file, change from read mode to append mode. You can also use the write mode by changing this to W, but like I said before, if you use write mode, it will erase everything in the file and replace it with whatever you're writing. So obviously we don't want that. We want to just add our lines to the end of the text file. So we're going to use append mode. To actually write to the file, use the write function. So type f.write and whatever you want to add. So I'm going to start with a new line, hello world. Add another line saying subscribe. Now when we run the file, python textfile.py, and go back to the text file. As you can see, we added hello world and subscribe. Files that contain non-text, for example, images and videos, are called binary files. You see I have this JPEG of the YouTube logo. We're going to use this as an example. To work with binary files is the same thing, except instead of R and W for read and write modes, you'll use RB and WB for read binary and write binary. So I've created a variable called input file, which opens up the YouTube image in read binary mode. Now that the file is open, I'll create another variable called image file, set it equal to input file.read. So this will open the YouTube image and read the file to see what's in it. Create another variable called output file, and this is going to create a new file since it doesn't exist. And I'm going to open it in write binary mode called new youtube.jpg. Now if I do output file.write and pass in the image file, save it, run it, creates a new file called new youtube.jpg with the original YouTube JPEG image. That's how you write the binary files. If you want to delete files, use the remove function, which is included in the OS module. So you have to import it. Import OS, and to delete the file, you would put os.remove and the name of your file, new youtube.jpg. Run this one more time. Alright, what's up everybody? Welcome back to part 8. This one's going to be about object-oriented programming. Object-oriented programming is just a way of breaking down your program into different objects that somehow interact with each other. The main concepts of object-oriented programming in Python are classes, objects, polymorphism, encapsulation, and inheritance. Objects are created with templates known as classes. A class is kind of like a blueprint. It defines what attributes and what methods the objects will have. An object is just an instance of a class. If the class is the blueprint, the object is a house built using the blueprint. Attributes are the properties of an object, like a dog's name, and methods are actions that an object can perform, like a dog barking. To define a class, start by typing class and the name you want. We're going to call it animal. Make sure it's properly indented like normal in Python. And type def underscore underscore init underscore underscore self name. Indent this one as well and do self dot name equals name. I'll break this down in a second, but go down here and do def speak self and do pass for now. First we create a class called animal. Then we use the init method. The init method is used to initialize objects in a class. It's also known as a constructor. Initializing just means giving the variables initial values. In the init method, we have two parameters, self and name. Self just refers to the current instance of the class, and name will be the parameter that we pass when we create the animal object. So we create the class, then we use the init method with the parameter self to initialize these attributes to itself. Next, we're going to create another class called dog and make it inherit from animal. So type class dog, in the parentheses put animal, indented like always, def speak self, and we're going to return f string self dot name says wolf. I don't know. Let's do another one for cat, but instead of says wolf, says meow. Now we would like to create instances of both of these, so start by doing dog equals dog. Remember the first one's capitalized, and the string we put here will be the dog's name. Call emoti. We'll do another one for cat. Cat equals cat Garfield. Now we have a dog and a cat object, and we want to call the speak method on both of these objects. So let's do print dog.speak and print cat.speak. Let's run this. And we got Odie says woof, and Garfield says meow. These are examples of the main concepts of object-oriented programming. We created the class, so of course we have class. We initialized the class with the attributes name. We gave the class a method. We created a new class to inherit from another class. You have inheritance. We also define the behavior of the speak method based on whatever your object is. And finally, we have two different objects created that are different but do the same thing, which is polymorphism. If you want to access an individual object's attributes, use the dot notation. For example, say we have another attribute in animal for their age. At age here, do self.age equals age to initialize this attribute. And then down here where we go to create the object, add their age. Then to access each individual attribute, do print whatever object. So I'm going to do dog dot name, and then after I'm going to print their age as well, dog dot age. Then we'll do Garfield's name and age as well, print cat dot name. Now run the file, and you see we have access to the name and the age attributes. Just like with modules, classes can be created and stored in separate files and then imported into your application to save space. Once again, create another Python file. I'm going to call mine class.tutorial.py, and I'm going to take all this class stuff, cut it, and paste it into class.tutorial.py. Make sure you save it. And then back in the original file, do from class tutorial import dog cat, save. It runs exactly the same. Yo, what's up guys? We've learned a lot so far in this series, so it's time to put it all together and make our first project. Let's get right into it. For today's project, we're gonna have a simple banking app that works in the command line. So we will have a way to check the user, deposit money, withdraw money, check your balance, and exit the program. Start by creating class bank account and def underscore underscore init underscore underscore, pass in self, account holder, and balance. Set it equal to 0. Now account holder and balance don't exist yet, so let's create them. Self.account holder equals account holder. And the same thing for balance. Self.balance equals balance. So we define a class called bank account and the init method with the parameters self, account holder, and balance will initialize itself, the account holder's name, and the balance whenever an object is created using the bank account class. Now we'll create another method for depositing, deposit. Again, do self and amount, and then do self.balance, and then increment the amount. We'll also print the new amount after depositing. Now we want to create a method to withdraw money, but we also want to check if you have enough money to withdraw. So start by defining withdraw. Again, def withdraw, then again self and amount. Now if the amount is more than what you have in your balance, print insufficient funds. Else, take self.balance and decrement the amount. And we'll also print our new total. Now we also want to be able to check our balance, and that's easy. We just define check balance, pass in self again. All we have to do is just print the self.balance variable. F string count balance self.balance. Preface this with a $sign. Now we want to define the main function of our program. Start by defining main. First thing we're going to do is welcome the user to our program. So print welcome to the simple bank app. Set the account holder variable to equal the user's input, or what is your name, and make account an instance of bank account, but pass in the account holder variable. Now do while true. We're going to print all the options we have in our app. So print new line options. If the user enters 1, deposit money will be selected. If the user enters 2, the withdraw money option will be selected. If the user enters 3, we will check the user's balance. And finally, if they enter 4, we'll exit the program. Now create the variable choice. Make sure it's inside the while loop, and make that a user's input as well. Choose an option. If their choice is 1, the deposit money method will be called, and the user will be asked how much money they would like to deposit. So put the variable amount to equal, we're going to do a float, but you could do ints as well. Float, make this a user's input also. Enter amount to deposit, and then use the deposit method on our account. Account.deposit, pass in amount. Elif, their choice is equal to 2. We will do the same thing, except change this to withdraw and this to withdraw. Elif, again, their choice is 3. We'll call the check balance method on our account. So account.checkbalance Elif one more time. Choice is 4, print goodbye, and break. If the user enters anything else, we'll print invalid. And now we created the main function, so you must remember to call it. Okay, a recap before I run this. We create the class of bank account. We use the init method to initialize itself when bank account is used to create an object. It creates itself with the account holder and balance variables. Then we have a method to deposit money, which takes our balance and increments it by the amount we entered. And then we have the withdraw method that checks if we have enough money to withdraw, and then decrements our balance by the amount we entered. Then we have a method to check our balance, which simply just prints our balance. Then we have the main function, which welcomes you to the app, asks you for your name, and then creates an account using the bank account class using the name you entered. When the program runs, it will print you all your options. Your choice will be whatever number you input. If you enter 1, you'll enter the deposit menu, and you'll be asked how much money you want to deposit into your account. If you enter 2, you'll enter the withdraw menu, which lets you withdraw money from your account. If you enter the number 3, your account balance will be printed. If you enter number 4, you'll exit the program, and if you print anything else, you'll get invalid. Then of course we call the main function, make sure it's saved. Let's run this and see what happens. Welcome to the simple bank app. Lets me enter my name, gives me all my options. I want to deposit money, so I'm going to enter 1. I'm going to deposit $200. See, I deposited 200. My new balance is 200. Now I want to withdraw money. To amount to withdraw 50. Withdrew $50. New balance $150. Check my balance one more time. Here it is. Enter something invalid, like 7. Invalid. And if you want to just exit, enter 4. Says goodbye.